Hello, Dr. Dippins. This is Paul, and it's that time again where I demonstrate my Lab 3 binary input to you for the submission. This video is going to be a little longer than usual because I kind of wanted to explain to you the details of how I got this completed. By the way, throw my hats off to you because it's a great assignment that you have provided us. But let's get things started. So first things first, on Thursday, pretty much showed you my code. Pretty much I loaded the components, set all these things up right here. And then the switch count process along with the comments. Now the result of this program is right here. I've already pretty much programmed it. It is ready to go. So I'm just going to demonstrate this. So I'm going to click switch on one switch. Boom. As you can see, the 7 displays shows 1. I'm going to switch on 2 more, 3, 2 more, 5, 6, 7, 8, 9. Now, as soon as I hit the 10th switch on this 7 display digit 2, it's already set to 1. But the program have this just turned on to, it just turns off. So technically, if all these lights are on, it should show up 0, 0. By the way, digit 3 and 2 are set to 0. But digit 2 is set to 1, so it should show, if all these lights are on, it will show 0, 0, 1, 9. But I've disabled digit 3 and 2. And because the switches are on 9, I've also disabled digit 1 as well. Now, as soon as I turn this on, it will enable this and minus that 10 switches by 10. And 10 minus 10 is 0. And that will be what's in this value right here, digit. As you can see, if switch count is greater than 0, then I am going to enable digit 1 and then assign digit value integer, switch minus 10. So 10 minus 10 is 0. So because digit value 0 is 0, I'm going to assign digit 0 value to 0. That way, this is showing 0. Now I'm going to continue raising the switches up. 16, lower them up, lower them, lower, and it's 0. Now, the hardest part I had, hardest challenge I had was, honestly, it was the test bench. Now, you did show us a code for us to use, which is this right here. Test bench clock. Now, I noticed, I had to decipher this for quite a long time to make this work, but procedure test bench clock. So it takes 3 types of quote unquote parameters: constant period in time, signal done in Boolean, and signal clock without output standard logic. Now, when I was deciphering this, I noticed right here, when done, which is this Boolean right here, is not equal to true, then it would loop and make clock cycles. But when I notice on the bottom right here, I honestly didn't know what to put in for my done and my clock. So that's where the problem came from. So what I did was I kind of, tried all kinds of different stuff, and I modified your code a little bit. So instead of my done, I've chose signal as my count as integer. And then if you notice right here, when count, which is a new variable that I created, which is set to 0, when count is not equal to my count, now my count I've set right here as a signal for integer for 30. So what I did was, when count, which is set to 0, if it is not equal to 30, it would loop and it will generate clock cycles and increment the count by 1. So it creates 30 0 1 0 1 0 1 0 1 0 1 cycles. What I've also noticed was that on your code there was this statement right here called wait. So the problem that I had is, if I copy this test bench clock procedure, I had no way of changing this done as true so that this while loop terminates. And even though if it does terminate, it has this command right here that says wait. So the test bench procedure wouldn't end. Therefore, what happens is it would generate the clock cycle, but the test bench procedure wouldn't end. And I guess at that moment, I couldn't put in different types of switch values into it. So this is how I did it. Test bench clock, I put a little counter inside this test bench clock procedure to generate 30 clock cycles. Now, obviously, the period is 2 nanoseconds. And the reason why I did this is because obviously the test bench waveform can't create, it doesn't go past 1000 nanoseconds, which is 1 microsecond. So because of that, and also I also realized, I think this is why we have to use this option, because there is a component inside, there is a 7-segment driver component inside Lab3. And if I use a behavior simulation, it won't give you the actual output. So I had to synthesize and then implement and then run post functional simulation to actually generate the waveform and the output for the actual output after the implementation, I guess. So this is what I did. But before I start the simulation, I also wanted to implement that on the 7-segment driver. Remember, you had the count 1 kilohertz. Now this used to be, this used to be 100 million divided by 1000. But if I put this in instead of 2 right here, or anything low, the anodes wouldn't like toggle. So because of that, for this simulation, I'm going to use 2 right here. Now, before we run the simulation, I also wanted to kind of ask for something. I mean, kind of like, I guess show you something about my lab report. Here's the block diagram, but I put it in, in the vertical because it was too big. So I'm just gonna go over the block diagram right here. So as you can see, we have switch, and I made the lines thicker. The switch input goes to the switch count. Now, this might be a little overkill, but this might be a little overkill, but what I did was I mentioned that this is a signal digital value. This is connected to the signal digital value. Signal digital one blank. And I've also show that constant as well, and it goes in through digit 0, and this signal digit 1 blank goes into blank 1. I've also set the digit set to 1. Like I put in like the constant on top of these like stuff right here. I don't know if this is the overkill, but please feel free to give me a feedback, clock and everything. Put the definitions for all the constants right here. And now I'm sorry I had to put this in, a vertical rotation, but I had to do what I had to do this so that you can hopefully you can fit, I guess. But anyways, I'm gonna go ahead and show you the waveform, and please bear with me. I know this is a long video. I'm sorry. So I'm gonna go ahead and show you what I got, and I'm gonna explain to you, also try to explain to you as best as I can about this for this waveform as well, in a timely manner. But pretty much, yeah. So now this is what I got for the waveform, with the count 1 kilohertz integer 0 2. The reason why I had to do that is because like I wanted to show that the anode is anode at the segment is showing like within this waveform. So pretty much here it is. So we have switch right here. Switch, there's no switches on right now. As you can see, this is all 0. Now if you look right here, segment, this is 1. This represents the 0 segment. If you put this value inside the seg output, it will display the number. This will display 0. And as you can see, the anode 1110, which means this will enable the very right digit, like this. Now I also mentioned on my code that, I think we talked about this, but pretty much the second digit is always set to 1. So this right here, now switch is still 0 right now. Switch is still 0. This right here represents the digit 1. It's just displaying 1, but it's not displaying. As you can see, the anode is all 1s, meaning all the 1 doesn't get to display in the 7th segment. Digit 2 and 3 are set to 0 on default, and they are not displayed either. Now if we turn on our first switch right here, now as I mentioned, this is 1, but it's not displayed. Digit 2 and 3 is also not displayed. Now right here, one switch is on, and this represents 1111001. It actually displays 1 on 7 segment display, and as a matter of fact, on the anode, the very right digit it displays the number 1. And as you mentioned, it because like a human eye can't really like figure out like see how fast it's moving. So while this switch is on by 1, you can tell like it's showing this like these are the value that goes into other digits, and this one right here is the one that goes into the right digit. 2, same thing. Like this 0 right here is not shown in the 7 segment display, but this right here is the value for the 2 for the 7 segment, and it's displaying 1 for the 2nd digit, blah blah blah, and it goes on and on and on and on and on. So I'm gonna go ahead and skip this, scroll this to let's say 15 right here. So we have 15 right here. So this right here is the representation of the 7 segment display for 5, and this right here is the representation for 1, and it's actually displaying on the 2nd digit. Same thing with the 16 right here. I'm gonna go ahead and scroll this a little bit. Oh, what's going on right here? See how it kind of cuts off at 1000, but pretty much I guess you can kind of see it right here. It's a very small one right there, but that shows 6, and this shows 1 in the 2nd digit. So this is the a waveform. So I pretty much oh, I'm sorry, here it is more right here. Yeah, there it is. Yeah, so yep, so 6 and then 1. It was a very very tough assignment to figure this test bench clock out. Please let me know how I can improve on figuring out how to use this test bench clock and the basic counter, if you can. But man, what an assignment! Here's the block diagram. So please feel free to give me a feedback, whether if it's positive or negative. And sincerely, Professor, thank you for making me a better engineer every day. Seriously, this has been it's a very it's a very harsh time to learn, but I'm learning a lot. So thank you so much. Although you didn't reply to my email, but I mean it's something that I have to work out. But yeah, feel free to give me any feedback about this. Thank you so much. I mean, if you're really watching this video until almost 19 minutes, I appreciate it. Thank you, and I'll see you in about 3 hours or so. Okay, hope to see you. Bye bye. Thank you.